Eighth learning objective in section 4.2 is to describe how changes in variables such as sample size, standard deviation, or confidence level affect the margin of error and the width of the confidence interval. We will normally compute confidence intervals using GeoGebra, but to answer this question, it's helpful to look at the formula for computing a confidence interval. To compute a confidence interval for the population mean, we take x bar, which is the sample mean, and add and subtract t star times s over the square root of n. That t star times s over the square root of n is called the margin of error. It's the piece that we're adding and subtracting from our point estimate. So let's look at the pieces that go into the margin of error. There is t star, which is how confident is affected by how confident we want to be. That's our confidence, our critical value based on the confidence level. S is the sample standard deviation, and n is the sample size. If that margin of error is larger, then we're adding and subtracting a bigger piece from the point estimate, which makes the interval wider. If the margin of error is smaller, then the confidence interval will be narrower. So that margin of error is larger if t star is larger. That happens if we have higher confidence. So the more confident you want to be, the wider the interval needs to be. This makes sense because if we want to be more confident of capturing the parameter, we should include more likely values for it. S also affects the margin of error. If it is larger, the margin of error is also larger. This also makes sense because if there's more variability in the data, then there should be more variability or larger spread in the confidence interval. The sample size is in the denominator. So it's the square root of n, but as the sample size increases, that square root of n would also increase. When you divide by a larger number, then the whole thing becomes smaller. So when our sample size is larger, the margin of error is smaller, which means that our interval will be narrower. This also makes sense because if you collect more data, you should be able to be more precise in your estimate. So you could have a narrower interval if you collect more information. So let's look at this example. A 95% confidence interval for the mean commute time to work using a sample of 50 adult Americans was computed to be between 18.9 minutes and 29.5 minutes. Which of the following would produce a confidence interval that is wider than the one computed? Circle all that apply. Answers A and B talk about the confidence level. The interval that we were given is a 95% confidence interval, and we want to know which would make the interval wider, a smaller confidence level like 90% or a larger confidence interval or confidence level like 99%. As I already explained, if we want to be more confident, then we need to include more likely values in our interval. So higher confidence, like using 99% instead of 95%, would give us a wider confidence interval. A smaller confidence level would give us a narrower confidence interval. C and D talk about the standard deviation of the sample. That's the value for S. If S is larger and there's more variability in the sample, then the margin of error is also larger, which makes the interval wider. So having a sample with a larger standard deviation would give us a wider interval. A smaller standard deviation would give us a narrower interval. Answers E and F talk about the sample size. E talks about having a sample size that is smaller of 25 Americans versus 50, and F talks about having a larger sample size, 100 Americans versus 50. As we explained before, using a larger sample size makes that value for n bigger, meaning we're dividing by a larger number, which means the margin of error will be smaller, which means the interval will be narrower. So using a smaller sample size would give us a wider interval. A larger sample size gives us a narrower interval. And finally, answers G and F talk about having an outlier. An outlier in the sample affects the value for S, the standard deviation of the sample. If you have an unusual value, it will be far away from the mean, which will give the value of S a larger number. And so if we add a data value that is an outlier to the sample, S will be bigger, which makes the margin of error bigger, which makes the interval wider. Removing an outlier from the sample would make S smaller and the interval narrower.